Hi guys, in the given question there is a right circular cone which is placed on top of a hemisphere. Now this solid is placed inside a cylinder. The cylinder is filled with water. We have to find the volume of water left in the cylinder. So if you look at the figure over here, there is a right circular cylinder, and inside the right circular cylinder this solid is present. This portion over here consisting of this cone and the hemisphere, it's solid. We have to find the volume of water left inside this cylinder. So you will see the water that would be left in this portion only, which is not occupied by the solid. So the volume of water left inside this cylinder, what would be the volume of water? The volume of water left, you will see that would be equal to the volume of cylinder minus the volume of this solid. Now solid, quite clearly we can see that's a combination of a cone and a hemisphere. So the volume of water we can write, volume of water left we can write that's equal to the volume of cylinder minus the volume of solid, that would be volume of cone, plus the volume of this hemisphere. Now let's come to the dimensions. Radius is same for all of them. Quite clearly you can see as the figures are exactly fitting inside the cone and the hemisphere, they're exactly fitting inside, their circular areas are coinciding. So radius is same for all of them, that's equal to 60 centimeters. Let's call the height of the cylinder as h1 and the height of the cone as h2. So the volume we will get, that would be equal to volume of cylinder, it would be equal to pi r square into h1 minus volume of cone, that would be equal to 1 by 3 into pi r square into h2 height of the cone, plus the volume of hemisphere, that would be equal to 2 by 3 into pi r 2 by 3 into pi r cube. Let's simplify this equation a little further. So it's equal to pi r square h1 minus 1 by 3 pi r square h2 minus 2 by 3 pi r cube. From this equation, what I'm going to do, let's take pi r square common outside. So it would be equal to h1 minus h2 by 3 minus 2 by 3 into r. This is our equation. Now let's substitute all the values. Pi r square, so it would be 22 by 7 into 60 square multiplied with h1 height of this cylinder, that's known to us, that's equal to 180 centimeters, this total height. So 180 minus h2 by 3 height of the cone, that was equal to 120 centimeters, so 120 by 3 minus 2 by 3 times radius, which is equal to 60. Let's simplify this further a little bit. So we will get 22 by 7 into 60 square 3600 multiplied with 180 minus 120 by 3, that would be 40, minus 2 by 3 into 60. So that would be equal to 20 into 2, 40 once again. This value 22 by 7 into 3600 into 180 minus 40 minus 40, that would be 100 only. So this much is the volume of water left inside this cylinder in centimeters cube. Now since it's a very large value over here, so what I'm going to do, I'm going to divide this by 10 to the power 6 so that it gets converted into meters cube. So into 100 divided by 10 to the power 6 meters cube. Now this volume we are having over here, it's in meters cube. Now if you calculate this value, guys, this value would approximately come out to be 1.131 meters cube. This is the volume of water left inside this cylinder.